Hello everyone, in this video I'm going to explain insertion, then post order, in order and pre-order traversals in a binary search tree. So the basic condition for binary search tree is that the element in the left child should be lesser than that of the root, and the one in the right child should be greater than that of the root. And this should hold true for all the nodes in the tree. Now, as far as the program is concerned, here we are creating a structure node and having uh, variable data of integer data type, and we have two pointer objects, node star left and star right. And as far as the insertion part is concerned, here we have a pointer monk which moves from node to node. And here, suppose when the root is equal to null, that means there is no element in the root. The data inserted by the user, which is a, is stored in root, and it is returned. Else, we're checking if the data inserted is greater than the root, at which point we will move to the left side of the node and check if it's null. If it is null, we will insert it in that node. If it is not null, and we'll again check if it's greater than the element there. If it is greater, we'll move towards the right, or if it's lesser, we'll move towards the left. This is basically the logic behind this. So here you can see the if a, which is the element we've inserted, is greater than monk pointing to data, we are moving to right. If it is null, we are assigning it we are assigning it temp to monk to right. If not, we are moving to right. And if it is lesser, we are moving to left child. That is basically being done here. And as far as the in-order traversal, we are following the order of left, data, right. So monk would initially move to left, and it will, once it's moved to left, and it can no longer move to left, it executes the next portion, which is data. So it displays the data. As you can see, cout temp points to data, and after displaying it, moves to right. And if it can't move to right anymore, again this it goes to the previous node through from which it was first called for left, and it prints that node's data, and then after printing that node's data, it moves to the right node. This is the uh, order in which in-order traversal occurs. And for as far as pre-order, we have the data printed initially, which we have through cout 10 points to data, and then we have the monk pointer moving to the left, and once it can no longer move to left, it moves to right, after which it goes back to the previous node, and then goes to the right side and performs in the same hierarchy of execution. And as far as post order is concerned, here, if it is temp is not equal to null, we are following the hierarchy of left, right, and data. So basically, first it moves to the left most, and once it cannot move further left, it uh, checks for the right side. If right is also equal to null, then the data is printed. In such fashion, all the data in the nodes are displayed through left, right data fashion. And as far as int for the main function, here we are having a while loop, and we are calling each of the functions through switch case. And in first case, we are having the insertion part. In case 2, we have in order. Case 3, pre-order, and case 4, post order. And we have a default cases wrong entry if any other numbers given. And let's execute the program. 12. So as you can see, for pre-order, so these are the different traversals through which the data is